Welcome to One Question at a Time, the SAT series. Question number 82. The lines shown in the above diagram have equations x minus y equals 3 and 3x plus 2y equals 6. Of the five labeled points A through E, which one is in the solution set of the following systems of inequalities? X minus y less than 3 and 3x plus 2y less than or equal to 6. To begin with this problem, we always remember this is the line, so it's the same thing as linear equations. So we always want to represent y equal mx plus b. Ym is the slope of the line, b is the y-intercept. And what is y-intercept? Y-intercept is when x is equal 0. And the point represent y-intercept is 0, comma, y-intercept. Okay. So first we have to represent which one, we have to label which one is x minus y equal 3, which one is the line of 3x plus 2y equals 6. So we have x minus y less than 3. We imagine if we have x minus y equal 3, we'll solve for y by minus 3 both sides, right? And add y both sides. Why we do that? In this side we isolate x, right? But at the same time we isolate y on another side. We move the 3 to the left and then we move the y to the right, so that you have y equal x minus 3. It's the same thing as y equal x minus 3. If you're not familiar with that way, we can just do step by step. Equal 3, we subtract x both sides. We have negative y equal negative x at 3. Now we multiply both sides by negative 1. So it's become positive y, because negative multiplied by negative make it positive. We distribute that negative 1 inside of the parenthesis. Negative 1 times negative x is positive x. Negative 1 times positive 3 is minus 3. It's going to be the same thing. But if we just need to isolate positive y, we know that if we add y both sides, that will have the problem more straightforward. And if we know that is left hand side equal to right hand side, so when we set the right hand side equal to left hand side, is nothing changed. Okay, so at the same time we saw like that, so we just need to add y both sides, then we subtract 3 both sides. Okay, this one isolate the y, so we have y is greater than x minus 3. Okay, so this is one of the inequality. How about if we use this method to solve for it? It's still okay. So x minus y less than 3. We want to move x, we subtract x both sides, right? So now we multiply both sides by -1. So -1 times -y, okay, minus x plus 3 times -1. This one is a big note right here is when you multiply with the negative numbers, the inequality will change the sign. This one is the same for the equal, but for the inequality, it will be harder if we forgot that. By avoid doing the multiplications of the negative numbers, I will avoid the error. Okay, so we just want to isolate y, we add y both sides. And if we solve for that and we still remember the note right here, when you multiply with the negative numbers, the equality will change the sign. And we continue, you will have the same thing, y greater than x minus 3. Okay, it's the same. Okay, so next we have 3x plus 2y that less than or equal to 6. We need to solve for y as well. So how we, first of all, let's say this is the line represent on the graph above, right? So which one is y equal x minus 3? So we know that the y-intercept will be at 0, -3. So 0, -3 is right here. This is -3. Okay, so this line have to be y equal x minus 3, or it's the same thing at x minus y equal 3. So the rest, we only have 2 lines, so we figured out once. The rest will be another one, right? So let's do green. This is 3x plus 2y less than or equal to 6, and it will be the same thing as what we will solve right now. So we minus 3x both sides. Okay, this gone. We have 2y less than or equal to minus 3x plus 6. Then we divide both sides by 2. We have y less than or equal to -3/2 x plus 3. So we also see this is the y-intercept. If we solve for 3x plus 2y equals 6, we will have the same thing, right? Subtract 3x both sides. Then we divide both sides by 2. Then we will have y that equal minus 3 over 2x plus 3. Okay, so in this case, at 3 right here, that is 0, 3 is the y-intercept for that line. So we see this one right here is 0, 3. This point right here is 0, -3. Okay, so this one will be y equal -3 over 2x plus 3. So this graph is the green line. Okay. Now we have to solve for the inequality, and we have 2 lines. We need to make the solution set based on that. So y greater than x minus 3. y equal x minus 3 at the line. Above that will be greater than x minus 3. So let's highlight it with yellow. Okay, y greater than x minus 3. This is the reason above the y equal x minus 3. So it's greater than, it's strictly greater than. So the point B right here, point B right here is not, B is not inside of y equal or y greater than x minus 3 because it's on the line, so it means it's equal to the line y equal x minus 3. Okay, just making sure. For this one, we have actually when we represent the strictly greater than or less than, we will use the dash line like this, so it means it's not include any point like on that line. Okay, so for this one, we will represent the solid line just like the picture. So it's set y less than, so less than that line means it's below that line. So we can highlight it with the blue part. So below it is this part. Okay, and which one is intersections of those two? We have letter A. A is belong to y greater than x minus 3 and also belong to the set of y less than or equal to negative 3 half x plus 3. Here is A. So point A is in the solution set of the following systems of inequality. Just one note here, if we have the line laid out like that, right? Above is y greater than something, below is y less than something, right? So if we turn the line steep like that, this part is still above, this part still below. Or like this, y greater than a numbers, y less than something, right? So we have three cases. If horizontally, we already know is above and below easy, but making sure we're familiar with how it looks when we have the slope positive and we have the slope negative. Okay. Thank you for participating in this series and see you next time.